dire non. Tout va bien, ce serait mentir, oui, de le dire. Je ne peux pas dire non. Tout va bien, ce serait mentir, oui, de le dire. Je ne peux pas dire non. Tout va bien, ce serait mentir, oui, de le dire. Mais ça va toujours mieux, mieux dès le soir. J'oublie tout, c'est bien trop dérisoire. Mais ça va toujours mieux, dès le soir. J'oublie tout, c'est bien trop dérisoire.
Hi, everybody. Welcome to our Failure Symposium. And participants are Christophe Phillips, Badhwar, and Cyril Pernet. And what we've got for you today is a presentation and some discussion. And so let me put up and share my screen and go through what we're going to talk about. So let me give you a quick roadmap of what we're going to do. We are going to talk about 5 types of failure. Cyril Pernet is going to start us off with failures in thinking and planning. Christophe will take us on to failures in acquiring and analysing. I'm going to talk about writing and funding and then move on to publishing and reviewing. And then Aman is going to talk about mentoring and managing. We're going to have some questions during each brief presentation, if we can get to those. And also we'll have a general discussion at the end. So over to you, Cyril. Before I do, though, let me define failure. Lack of success, neglect or omission of expected or required action, the action or state of not functioning. So if we're talking about experiments or research questions, failure could just be seen as something that doesn't get answered or because of an error that's been made or a lack of something. Okay, take it away, Cyril.
Okay, so let me state it that way. We know that there's no failed experiment, right? Because all we read about, we all read about these hypotheses that are confirmed, and of course we all have enough statistical power to show the effects of interest. But all of this is a logical error because we are concentrating on the people or things that made it past some selection process. And so this is called the survivor bias. Next slide. And so if we look at social gathering like this week OHBM, also in social media, you know, our favorite Twitter and Facebook, this can make things worse because actually what we do is celebrate successes all the time. And also what is good research or trendy research. So this must not be a template to find achievement. So if you think about theories and ideas in general for science, this cannot be proven by a single experiment. Usually, this is an accumulation of evidence that keeps the theory alive. And so all we can do really is disprove, which is basically what we need to do is to fail to find an effect. That's actually the right way to get through a theory. So, of course, it's hard to publish any kind of negative results, but this is really what we should try to do. Yeah, next slide. And so here is a quick survival success. Recently, I posted a preprint on Twitter. Okay, I got a couple of people looking at it, some engagement. So I take it as a win. I'm happy the paper is out. Now I send it under review. All good. Next slide. So often what we do with papers, we have sometimes intuitions about what the paper is going to be. But if you look, that's my GitHub thread on the right-hand side of the screen. If you look at it, this actually started 7 years ago. 7 years to make a paper. And so my student at the time did a really great job. This is a procedure to estimate some statistical summary statistics, and it worked fine, but I couldn't get inference right, and I keep failing. And 7 years, where from time to time I would go back to it, and I keep doing it, and I keep failing all the time. But of course, this year we had plenty of time to play with computers, so I finally got it right. Yeah, next slide. And so I could have chosen to present another study than this one. Now, of course, I couldn't, because I simply don't have any paper about those failed experiments. Like everybody else, we don't have papers about those. This one is because our luck is I finally got it sorted. And so I'm guilty like everybody else, that we do not show all the experiments that we do and fail. But this is actually how science should progress. We should be able to learn from failure. So what I'm trying to say here is that what would be really important to us is to be able to move from a culture of success to a culture of progress. Yeah, last slide. And so what question I have for everybody here is what changes can we make to recognize all these efforts that we spend, trying and persevering and making mistakes. But, there's plenty of things that I don't say in that paper that fail. And this is the real life research, right? The time we spend failing. And I think it worth as much as the 99% of every other successful research. And I put 99 because I leave out this 1% of truly changing stuff like COVID vaccine. But if you look at that paper from Fauci in Science, even this vaccine relies on years of tiny, small incremental successes and a lot of unnoticed failures. Thanks.
Thank you, Cyril. And we'll keep moving through things, and then we'll remember this point as we go through. So let me move on to Christophe Phillips now and his presentation.
Thank you, Aina, and hello, everyone. So I'm focusing on more some technical aspects that we're facing in the lab. So I used here a little adage from a computer scientist. There are a few of them, like the bug is usually between the keyboard and the chair. There are old ones like Murphy's Law that says anything that can go wrong will go wrong. And that's exactly what can happen on the course of an experiment in the lab because of the whole complexity of everything that we're using. So next slide, please. So here, I'll discuss a few points with data acquisition. How can we fail or can we get ourselves in hot water with data acquisition? Well, there are problems that can arise at multiple levels in terms of equipment. First, things can get replaced, updated, changed, and these things can happen with your knowing. I mean, if you replace the MRI scanner in the lab, that doesn't happen over the weekend, but that's sometimes something you cannot avoid. So you have to factor that in. Now, updating or changing some peripheral equipment, that can happen during the week without your knowing, and that can be a problem with keypads. Wires have been changed, and things will not behave as expected. Other things that could go wrong is quality issues. This is more of a random problem. You acquire data and you take things for granted, and then for whatever reason things are not working as expected. The data are noisy, or the signal is not good enough for your analysis. That means that's something at least you can check, and stuff like quality assurance, quality control are needed. And this the third point that's related to the previous one, misplaced expectations. You trust things not to change, and they change. They don't change overnight by themselves. It's because someone does it without thinking about what influence it can have on someone else's work. So don't trust the others in a good way. And finally, this trust thing should be part of the procedures you put in place when acquiring the data. With a simple set of instructions, people will typically do things in a slightly different way, and those ways can introduce at best some randomness in your data, but could also introduce some bias, and that's something obviously we want to avoid in order to obtain clean data. And these are all problems that most of us after a few years have experienced. And that's something we typically discover afterwards, and we learn from our mistakes. Well, at least hopefully we learn from our mistakes. Next slide, please. Yeah, so that's the issue about systematic versus random problems. And in both cases, you need to look into these potential problems. Next one. Yeah, no data. So you get the data, they're all clean, and you want to move on with the analysis, because the ultimate goal is publication of your great experiment. There is no failed experiment if you've acquired the data correctly, but we still need to milk the data and get the juice out of them. And here, that's where computer gets really involved. And the first thing is data are your goals, and you should be careful with what you do with your data. You wouldn't leave a heap of money on the table in a room open to everyone. So you shouldn't be just leaving your data lying around and them not being carefully curated, protected, backed up, versioned, and everything. So you need to ensure safety, security of your data. With data processing, we're not writing things on paper. We use computers. That means software, and there comes all the issues of different software, different updates, different versions of the code, and it's difficult to get good solutions with there, but you should at least be aware exactly of what you've done. So traceability is critical. The third point is the third and the fourth are related: poor planning and an analysis procedure. That's something you should think about before acquiring the data rather than after. If you don't know what you are looking for and in minute details, then everything can be results. Everything that shines is not gold. So you want to be aiming for something. You may find something else, but at least you know what you were aiming for. And otherwise, I mean, discuss with statisticians like I know Tom Nichols is a big fan of these issues of multiplicity of tests. If you test anything, in the end, you'll get some results, but that will be after too many trials left and right. And in the end, also, when you get some results, interestingly, you should be able to trace back the path followed by the data from the moment they arrive on your hard drive to the effect size and the p-value that you've just calculated. So next, please. Yeah, so it's all about reproducibility and reliability of your data. You must be able to be confident in what you are obtaining. And next, please. As a conclusion, we should not take anything for granted. Shit happens, and it happens all the time. Small one, big ones, but that happens. And we're all fallible humans. We make mistakes, and that will happen. So rule of thumb is sanity checks, procedures, plan for errors. What if you've got some plan B, some way out, it's better than nothing. And interestingly, one really central element, we're not working alone. We work in teams, and communication of information is crucial. So by communication, I'm not just saying, you don't just give instructions, you ensure that instructions are understood the same way that the way you are expecting it to be understood. That's the central part. And with that, I pass over to Aina. Or maybe we go for discussions, I don't know.
We have a one comment in here in our chat, an endorsement from Cyril's earlier point about the progress over success, and especially if progress is defined at the community and global level. And I think that's a really important point, particularly as we deal with these larger data sets. And this meeting, we're seeing a lot of abstracts with incredibly large teams working together, and with the word team in capital letters, and that's what Christophe was mentioning already earlier. So let's move on a little bit now and to the next one. Thank you, Christophe. And this is all of us have put our heads together. And I drew the short end of the stick and have to talk about writing and funding on behalf of everybody. These are all of our ideas together. And how to obtain a bad grant review. How can you go about that? Well, let's tell you how. Don't read the instructions. That's an absolute classic one. And as a grant reviewer, I love that one. That's one of my favorites. Individual versus consortium applications have different caveats. So, people often can't switch between those. The ambitious proposal. Trying to do too much and not being realistic. That can tank proposals, even though the work proposed is good. No proof of concept, of course. That's a big one, because the studies mightn't be feasible in the reviewer's mind, at least. And the dependent specific aims. Okay, one aim depends on another, so then there's a domino effect if the first aim fails. Not a good idea. And then not acknowledging limitations. As Christophe said, look, we're not perfect. We're going to make mistakes. We've got, we need plan Bs, and we have to acknowledge that. And we have to acknowledge that in the proposal, because if we don't, that will give the reviewers doubts about whether we'll be able to succeed if something unexpected happens. And then, of course, we can't overinterpret the findings. We have to call a spade a spade. The other thing that people do not do enough of is not sharing grant drafts with trusted colleagues and not getting other opinions on their proposal. This means getting it done early, giving your colleagues enough time to tear it to shreds, and giving you enough time to put the pieces back together. Very, very important point. Strategic errors. And strategic errors, some examples, just thinking about a good strategic error to think of is you have a funding institute and you don't write to their mission. That's one example I can think of off the top of my head. Not addressing sex and gender issues properly. And this, of course, in this day and age is very, very important because it impacts not only basic research, that taps into clinical research and healthcare ultimately. And then beware of the hyperlink, because some grant funding mechanisms don't allow hyperlinks in their proposals, and proposals can tank because of that. And so be careful about that. And that goes back to point number 1. If you've read the instructions, you're not going to make that error. Don't create problems at the last minute. Don't tinker with it. It's not going to be perfect. Just go with it once you've checked it. And then if you do go to resubmit and deal with every issue raised by the reviewers. Okay, now these, when you put this list together, it's basic common sense, isn't it? Of what not to do. But how many people actually do these things? And a lot of people do, particularly if you're a reviewer on a grant panel. So that's that failure from all of us. And let me just check the chat. And we don't have any comments yet in the chat. That's fine. I keep checking that. Let's move on to the next section. And this is publishing and reviewing. And this is something that I do a lot of, reviewing. And like Christophe, I took a quote as well. And this kind of encapsulates my career, I think. Success is stumbling from failure to failure with no loss of enthusiasm. So that just encapsulates me. So let's take a look at this problem, this particular failure, from 2 perspectives. One is an author and the other is a reviewer. So let's look at the author ones first. A very important thing is the audience, the optimal audience, and the outlet for your work. And so if you haven't selected that properly, it's going to be difficult to publish your paper, more difficult, because that won't garner as much interest. And that may also apply, of course, for grant funding. I mentioned the strategic error before about not writing to the mission of the grant funding body. Yes, non-informative manuscript cover letters. That is a really important one for those of us who are editors. We need to know why you think your contribution is going to be good for the journal and what you found, and make it short, make it sweet, but think about it. This is a very, very important part of the application. People poo-poo that, but editors actually read these. Surprise, surprise. The other thing, follow the author guidelines and instructions. The reason why is we don't like it, but there are different electronic management systems for journals. Yes, that's the sad reality. These create PDFs that get sent out for reviewers. If those instructions aren't followed properly, the PDF won't be assembled properly and you will encounter lots of problems. And reviewers may encounter lots of problems, so don't do that. And I know it involves a lot of effort. Not declaring that data sets have been previously published. Why don't you want to tell people that you're reanalyzing data? There's no shame in that. Don't try and represent things as they're not. There's nothing wrong with publishing those data sets and analyzing work. It's a good thing. And let's let everyone know that. Suggesting reviewers with conflicts of interest, that's not a good thing, because people are relying on your integrity and your honesty. It reflects your ability to do science honestly as well. So make sure you suggest these things correctly, because it's going to reflect badly on you later, because editors check. We know. We do literature checks. We know who's being honest and who isn't. Not taking the reviewer's concerns and issues seriously. This is really important. You mightn't agree with what the reviewers say, and that's okay. But just tell, in your response to reviewers, tell people that, and respectfully do that, and tell them why and give them good reasons why. Okay, we're not going to do this because of this, this, and this. And, you know, most of the time reviewers are fine with that. Just communicate and have a dialogue with them. Poorly prepared appeals, if the decision goes badly, goes south, and you want to appeal, prepare your appeal properly and talk to the editor, because decisions can be reversed. Don't do it emotionally. Rely on facts and have a dialogue with the editor. And that's going to be good for everybody, you and the editor. Let's look at failures as a reviewer. Ignoring invitations to review, i.e. not declining them if you're not going to review. Do not do this. This adds delays, huge delays in the review process. Okay, and right now with COVID, this is why our manuscripts are being slow in many cases. We have to go through this chain of reviewers and people not declining. Very, very difficult time right now. Don't do that. Ignoring journal publication guidelines as a reviewer. The reviewers have to know what the mission is of the journal. Don't ding a paper on novelty if that journal takes negative results and reproduces studies. That's got no place for it in the review. Look at what the journal criteria are for publication. Don't do a content-free review. You've just wanted to do a review quickly in a couple of paragraphs and there's no content in it. We can see that. It doesn't make you look good as a reviewer. Don't mismatch if journals have scoring systems. Review content with your scores. Be consistent. We all get mad when we make reviews. Edit them before you submit. Take the effective content out. It doesn't make you look good as a reviewer. And do not decline to review manuscripts that you reviewed. The authors have revised them according to what you recommended. And then you ding them by not actually reviewing the manuscript. That's not fair on them. And also, if you're a new reviewer, sometimes this can happen if the person has declined, as I've just described. Respect the revisions that they've done based on the previous reviews. They're just trying to do the right thing. Don't ding them on doing other things, unless, of course, they've made some egregious error. But be fair to the authors. So that is my thing. We've got a couple of comments here in the chat. Someone's saying that they're starting to believe progress in science might be better served by a grant lottery approach. Excellent point. We'll leave this one to pick up at the end when we discuss. That's an excellent point. So let's all remember that one. And then another comment, a valued mentor with an amazing success rate for large grants once told me a good grant takes a full year to develop properly. Best advice ever, a rushed grant is a bad grant. I agree. It takes me 6 months to write one. Good advice. Okay, so let's move on to our last failure, and Aman is going to take us through that.
Thank you, Aina. So I guess I will be concentrating on the interpersonal aspect of research with mentoring and managing. So next slide, please. Okay. This is just a picturesque slide, but the contents in the next one, so we can move on to that. Perfect. So before I go into this, I know that the OHBM Student and Postdoc SIG has put a lot of effort in making their mentoring program last all these years and be successful. And I'm really happy to say that, you know, I had initiated that program because I really felt that mentoring was needed. So both me and Michelle Welsman had crucial roles in that program. So the way I'm going to approach my slides is failures from a mentor perspective and failures from a mentee perspective. I would like a lot of discussion. So I've just pointed out 5 important things. There are a lot of other important things that we can discuss during discussion. But I find that as a mentor, if you've accepted to mentor somebody, then it is really crucial to find the time to meet. I've been assigned mentors in the past where it's just been like, okay, let's meet, but then you're prepared to meet, and then the last minute email comes through where it's like, sorry, have to reschedule. And, you know, it just ends up that you just never end up meeting the mentor. So kind of, okay, if that breaks trust. It, you know, like there are different points in mentoring, of being a mentor that you don't want to do because you want to create that interpersonal relationship. You want to create a trusting relationship. As a mentor, we also need to be aware of the diversity of our mentees, and that not every mentee responds to, you know, the standard mentoring approach. You might have a mentoring approach that you're very good at, but it might not make sense to some of your mentees, and you need to be flexible. You need to change your mentoring style based on what the mentee needs. That might be a bit of a learning process as you meet with the mentee once or twice, or sometimes the mentee will come to you and go, you know, this is what works for me, this is doesn't, and then you need to listen and be flexible. The third point is using ineffective communication styles. I know when you're a mentor and a mentee, often you don't pick your direct supervisor as a mentor. You do, like in one sense, they're your supervisor and you learn a lot from them. But it is often recommended to also find mentors outside of your direct supervisor. And one of the reasons for that is that there's often a power relationship when you're working under somebody. Like I'm very careful of that in my lab. Like I love mentoring, but I'm also very aware of the fact that there's a power dynamics going on. And that kind of brings me to the ineffective communication styles. So even if you're not a direct supervisor, you are still an authoritative person. The mentee is kind of lower, you know, in the academic training circle, they have less qualifications than you. So maybe not use a very powerful, like you have to do this kind of communication styles. You need to kind of reach your mentee at a personal level and be a friend, but with a bit more experience, like an experienced friend. This is probably how you need to approach your mentee. Don't be abusive to them. Don't tell them that they're like terrible at something, or they could like, you know, why is it taking them so long to figure this out? So just be very careful that as a mentor, you can really damage somebody if you use like ineffective communication styles. And then the other mentoring mistake can be to pretending to know the answer to everything. Yeah, we often feel like we should, like somebody's asking us something and we're like, oh man, I don't know the answer to that. And I think it's better to say that to the mentee that, you know, I really don't know, but I can look it up and find out for you. Or you have a lot of experience in something and you say you know the answer and you can, this is how you've approached something. But there are mentors out there who, even if they don't know the answer, they'll give you an answer in a way that holds a lot of authority, and we need to be careful of that as a mentor. So as I said, a lot of the ways how you handle a mentee relationship affects whether you're building or breaking trust, and we want to be on the building trust portion of things and the breaking trust. So I know there's a lot of other tips and advice, but I'm going to stop at those 5 and then switch to a mentee perspective in the next slide. So what are the mentee elements of mentoring failure? It's pretty much the same as two elements are very much the same as the mentor one, which is not finding the time to meet and then breaking trust. And then one of the 4 of the other things are, you know, you go to somebody for mentoring purposes, but you're not sharing sufficient information. You want to appear to them like you know everything, what's best for you, and you don't really tell them why you've approached them as a mentor. Now, mentors are really relying on you sharing sufficient information on how you, like why you're there, why you need to be mentored. So, sometimes that information might be a little bit personal, but I'm sure you can relay an information in a way that it doesn't compromise you in any way, but gives the mentor enough insight to mentee you properly. So there's a balance in how much information one wants to share, but definitely share enough that it's beneficial to you. And not being open to feedback, that's important. You can get mentees who have a lot of self-pride, but obviously they're there because they need mentoring. But sometimes mentees can be sent to you by a department, and that you're there because you've been told like you have to be mentored, you're assigning your mentor. So there could be a pushback and you're not open to being mentored, you're not open to feedback. So that would clearly lead to failure. It's really a waste of everybody's time. So if you're there to be mentored, then you should allow that person to mentor you. Unrealistic expectations. Well, a mentor is just another person. They might have more experience than you. They often have more experience than you, but they cannot fix all the problems. So, like, even if they give you some useful tips, consider that as a mentoring failure, and don't have over expectations, because that will lead to mentoring failure on in your psyche at least. Lack of motivation. So a mentor is spending a good mentor is spending a lot of their time and energy providing you with tips or introducing you to networks, whatever your needs are. Follow up on that, like try to do the things they're suggesting, report back to them and say, this worked for me, this didn't. So that would be lack of motivation leading to a failure. So the next slide has an interesting quote. Since we're discussing failures, I found this quote and it really appealed to me, because it said, the greatest act of leadership is mentoring. No matter how much you may learn, achieve, accumulate, or accomplish, if it all dies with you, then you are a generational failure. It is a bit harsh maybe, but as academics, we do need to think about, what are we preparing the next generation to continue science in a way that we would like to see, for improvement of society. So I'll just leave that quote as is and move to the next slide, which switches topic a little bit. It's on management failures, and the slide after has a few pointers on that. And this is mostly in respect to a lab environment. I've mentioned a lot of these from a mentor perspective, but now it's more from a direct supervisor's perspective and things that could lead to failure. I think being unaware of power dynamics is important on my list, because if you don't have open communication, you can often tell people to do things in a manner that they would try to do and please you, but at what cost, and sometimes the work-life balance becomes important. So don't abuse your power. I mean, it's not even sometimes about work-life balance, it's just how you're telling certain things to be done. Are you taking advantage of people in your lab, etc., etc. Not engaging and interacting. So this obviously is a tricky one, because usually when you're an early career, you have a bit more time to engage and interact. And then as your responsibilities start getting a bit overwhelmed, maybe you don't have that much time to engage and interact. But there are still ways to integrate engaging and interacting that, the people in your lab do not feel like that they came to do something with you, but like say, and they wanted to do their PhD with you, but really they're not getting your attention at all, and they might as well have gone to some other lab to do their PhD. Because at the end of the day, we choose supervisors to a large extent because we are stimulated by the research we see coming out from their group. And, like interactions with them it really makes our days, like as when you're trainees kind of thing. So I think that's important to, given on your time constraint, to still find some time to engage and interact. Not effectively assessing performance. Well, I don't think I need to explain that too much, but it could lead to failures. Not empowering your trainees. We are there to train the future generation. We need to boost their self-confidence, especially when they're doing something right, so that they can, continue beyond us. That's one of our reasons that we're there, whether it's in academia or in non-academic positions. When a trainee has done, when they're on the right track and they're not making huge mistakes in their research, you need to empower them. Not knowing how to navigate cultural differences, I think it's becoming very important these days, especially because we're such an international scientific society. And there are cultural barriers that exist, and we are not trained as lab heads to maybe always deal with cultural differences. So maybe that's something we need to take a course ourselves or get trained in that, because it doesn't always come naturally. And sometimes we need to read about that culture and find out how certain cultures respond to certain things. And I think one of probably the most important and difficult thing to do in a lab with trainees, and I mean, when a lab personnel that's paid is not performing well, you maybe just say, well, look, it's not working out. Find a different job. But it's really hard to do that with trainees, especially if they have, if you feel like they're really not meant for the academic track, and maybe they're better for a non-academic track, which is just as useful and might stimulate them more. How do you come out and like prepare them for that? So there are these some of the things that are very sensitive and difficult topics to deal with, but needs to be considered in the lab environment. So I will stop on that and we can take questions, I think.
Yeah, we've got some questions, and I just want to share one final slide, which I can't now remember who engineered this. Was it Christophe or Aman or Cyril? I can't remember.
I did it. I'm
Do you want to take us through it? Take us through it.
Well, it's one of those sayings, like there are two kinds of people: those who do this and those who do that. And here it's putting the joke in the academic world. So there are those two kinds of researchers: those who have lost some data and those who will. That's my IT side. Those who trust their data and those who check them, because that's two different things. Those who click buttons, those who know what they did, because button clicking, well, it's easy to click on the wrong button. So scripting, pipelining, and things. Those who publish papers and those who never get rejected. That's also a classic. It's usual. Papers most of the time, unfortunately or fortunately, in a way, get rejected and hopefully end up being published with some improvement. Those who are funded and those who never get rejected, that's the same thing. Grant application is a difficult art, and beyond the science, there is also a bit of luck and timing. Being at the right moment, the right place, right moment with the right proposal is sometimes something we don't have control over. And there were a few more, but there was not enough space. So if we could start a trend on these, there are two kinds of researchers, and see what comes up.
Thank you for that. Just to as we get going with our discussion, we've got 15 minutes. The common themes that came through there were trust, and that came up a number of times, not just in doing research, but in actually dealing with people, mentoring, menteeing. And the I don't know phrase came up a number of times as well. Okay, and so that these are very, very important. We had a initial comment about a grant lottery. We've got some other questions here, but let's take a quick round of anyone want to take a stab at what they think about having a grant lottery?
That's a rabbit hole I don't want to be jumping in because it's Alice in Wonderland. So yes, to some extent, the lottery sometimes would do as well, and would mean less wasted effort in preparing the grant. Now, there is still a need to have good grant proposals. So if you know you're going to be pulled by chance, so what is driving you to still have to put in the effort to prepare something that really goes above and beyond what exists and gets you out of your comfort zone, and you open up to a new field or something. So maybe a lottery at some point where I understand the moment where all the projects are really good and it's difficult to balance or to pick one over the other, and there it's almost the flip of a coin. A reviewer says an extra good or very good or nice or nicest. Two letters would make a difference. That's random to some extent. So there it's in a way it's already happening through the hands of the panel and the reviewers, but it's true that can be unfair as well, because famous labs have probably some bias in favor of them, or the edges are not exactly the same. Mm-hmm. So yes and no.
Cyril, do you want to have a go? You've been very quiet. He's still very quiet. Cyril, can you hear us? Would you like to comment on that, on this issue?
In the chat, in our chat, but also in the room, there's actually a Netherlands, they are actually trialing this. So, yeah.
I see that in our chat, yes. That's really interesting. Someone has put in. Mm-hmm.
So the Netherlands are trying this, right? Where they actually do this. Well, I mean, as Christophe was saying, obviously there's some review first, but then after that, it's kind of lottery. It's a small scale, right? They're not doing it for like the whole country, but they're trying it because I think, in a way, it does have this aspect. Once you get the bar of, okay, this is a good application, well, it's a little bit of lottery, and then you fail, and sometimes you really don't understand why you fail, because it's like you got very good reviews, and yet somehow you still, the panel just said no, and you don't really have good feedback from the panels most of the time. So yeah, I'm not against it. I mean, I think once you get the reviews who says, okay, let's say everybody needs to have some above 80% or something like this, then why not?
Right, and Aman, you've just done a grant panel.
I've done several now, and yeah, I agree with Cyril, because so I should begin by saying that not all grant committees have such strict grant controls, I guess. Like the smaller agencies, it really comes to a lottery of the kind of reviewer you get. So you might have a very good grant and not get it because it's just bad luck, like sometimes you just get the wrong reviewers, and they should really just say, I can't review this grant, as opposed to try and judge it on different things. But for the national granting agencies, I feel like once you're in I know in Canada you have the different gradings, and then once you're in the excellent or outstanding range, like once you're in the outstanding range, at that point, it really comes down to very subjective opinions of the reviewer, to a certain extent as to whether they score it, whether they scored at 0.5 higher or a little bit lower, because the grant is outstanding. So I think once you're in the outstanding range, it won't hurt to go into a lottery system. The other thing that I've become very aware of, because a lot of time grants require a lot of resubmissions. And we need to be very aware of the fact that often the reviewers will ask things that requires work for extra preliminary data or more publications. And that can somehow become like a really bad cycle, because you're giving the reviewers everything they want, and then they keep asking for more and more and more. So you're basically doing all your research without much funding just to get that one grant. And I don't know what the answer to that is. But anyways, just was on my mind, so I brought it up.
Yeah, and we're just having, there's a question in the chat about whether we mean a grant lottery, do we mean completely random assignment of funds without an application? And that's not what we're talking about here. I think everyone has mentioned some initial peer review process to pass some threshold of excellence and feasibility of the proposal. And then within that criterion, perhaps then we could have a lottery of sorts. I'll just add, in the American system, grants, say, for example, to the NIH, get reviewed by the Center for Scientific Review, which constitutes these grant panels on certain topics. And those grant panels review things, and things can be in the outstanding range, but those grants go to different institutes. And then that depends very much on what the mission of the scientific institute is, and whether that's of interest to that institute and whether it will be funded. So there's another layer of that, something that we can't even control at the grant panel as well. So there's that aspect too. So that's, every country has a different system, but it's very interesting to hear that the Netherlands and France are experimenting with this. So we've got about 10 minutes left, and the rest of the questions that are coming in here are relating to mentoring, actually, and menteeing and mentoring. And there's one question which it's got a follow-up as well. So it's what do you think could be done to avoid the opposite failure of mentoring? That is, not assuming the role of supervisor and just acting as a colleague. And I can give you the follow-up, or do you want to have a go at that first?
You can give me the follow-up.
Okay, follow-up. For example, not directing enough and leaving your student alone during doing their own research, and wasting countless hours on trivial things, and and being overwhelmed by the complexity of science, publishing, and administration.
So I've had many supervisors over the year, and they all have different mentoring styles. And I've also had different mentors. I do believe in mentoring quite a bit. There are two extreme groups, and then most of us probably just fall in the middle. Some supervisors or mentors are really like micromanagers, and they really like to be on top of things and manage. Others are like, you're doing a PhD, figure it out, and that is the other extreme, like not much interference at all. And I believe the extremes of both might lead to a lot of confusion. So I'm pretty sure most of us try to balance in the gray zone or the middle zone there. I think, I can say this because I'm an early career researcher. I just became an assistant professor. I often thought when I was a grad student, like, oh, why can't my supervisor be more at a friend level with me, or whatever. Because I guess because doing research is a bit of a lonely business, and it's nice to have scientific conversations more with your supervisor, which does require more time. But as I transitioned to being a supervisor, I really realized that it's hard to become too friendly with your trainees, because at a certain level you kind of have to come and tell them like, hey, what I asked you to do this, why, where are the results? And if you become too friendly, just like, you have to, if a friend cancels on you, they cancel on you, right? Like, you have to deal with that as a friend, but it doesn't work like that in a lab. At least that's been my experience. But I also realize I'm just starting out. So I'd be happy to hear Aina's and others' experience with that.
Well, I can sum it up in one sentence after all these years in the lab. And as you said, everybody's different. I tend to be more like an intellectual parent. And I look at the people who are in my lab who are experimenting and doing new things. Will they always listen to their parents? No.
I think one aspect in the second comment was, not letting people spending a lot of time doing trivial things. And as a mentor, I think sometimes we fail to do that because it's like, okay, I explained that so many times that I don't want to do it. But I changed that practice, and actually it was from email and not from like directly speaking, which is like, if you have to explain it twice, you know what, make it an entry in your Wikipedia, in your protocol lab book, whatever tools you're using. If you're going to explain it more than once, you know that becoming something trivial that is done in the lab. Document it, put it somewhere. Then you can say to people, listen, this is there, and you can edit it, make it better, and then more people use it, and this becomes something that you use in the lab. And all the trivial things, you don't need to deal with it as a mentor, and the mentees are happy too, because they have all the resources. Possibly they can ask you a couple of questions, but I think it saves you as a mentor to explain these trivial things that you actually don't want to do it, because it's been done over and over. And for them, it's quite nice as well to have access to this information.
Christophe, do you want to weigh in? Do you have anything to add to that?
Yeah, to complement the relation is, it seems like there is a supervisor and a mentor, while in fact usually as a PI you work in environments where you have many people around. So there may be 2 or 3 postdocs that you are co-supervising, the few PhD students. So it's good to have one-on-one discussion, but not all the mentoring should just be one-on-one. And it's part also of the training of the postdocs to give them some responsibility to deal with, to help the PhD students. So they learn a bit of the tricks of the job. At the same time, that is relieving you from some tasks that are time consuming and can be a bit more better invested on other things. So in a way, you want to have some kind of a pyramidal scheme where you are good at a few things, and then you make sure that those who are helping you are almost as good as you are, and then the information can pass down the tree, and the questions also will come up. It's kind of, as Cyril put it, annoying when you have an obvious questions arriving to you by email, while it could have been answered by the person just sitting next to the PhD students. So, and even among the PhD students, I mean, a PhD student in the first year, he's a beginner, absolute beginner. He learns the job. But someone in the third year has been through many things, so it's good also to have PhD students relations, so that they help each other, and especially when you have a mixed bag of skills. And something we learned also in the lab, we share offices among several PIs. We don't want to be putting all the PhD students, all the researchers from one team in a single room. We always mix rooms because there's sort of cross-fertilization in terms of intellect, and they hear both things. Oh, that team is doing it that way, and then you also hear about how your colleague is proceeding, and that's typically the way of selecting what works and ditch what doesn't work. and there is more variability in how problems are tackled, and the whole lab atmosphere improves on top of increasing the intellectual level.
Yeah,
so
that's great. It's a very good point. And now we are having to face a wrap up now. This has been a great, I've certainly had fun and I've learned a lot, and we need to wrap up because people are going to have to be off to other things. So everybody, thank you very much for coming and listening. And thank you to my co-conspirators. Everybody have a good rest of the day.
And also to Natasha Clark for sending us the questions.
Yes.
So thank you.
Thank you. Thank you so much. Bye-bye.
Bye-bye.